This is a series of optimization playlists. In this series, there are conceptual part, coding part, and code, and concept linking part, to clarify the concepts about optimization. Optimization is a continuous process that begins with brainstorming and ends with implementation. Let's start with an introduction. In this video, you will have knowledge on the following topics. What is optimization? Optimization brief history. Why optimization is important? Where exactly are optimizations used? And we also summarize the different methods of optimization. Okay, let's continue optimization introduction part. Optimization is the discipline of continuously adapting a process to improve it. To do that, we need to do some analysis to identify our weaknesses and find solutions to overcome them. Specifically, optimization is the mathematical procedure of maximizing. The animation on the left maximizes profit. We want to get the maximum benefit, so our solutions aim to get the best results. Minimizing. The animation on the right shows that cost is minimized by maximizing location usage. A function over a set for minimization and maximization. It often represents the range of choices available in a particular situation. Optimization is essential to achieve the desired competitiveness and become a market benchmark against which other products are compared. Want to know more about what process optimization is? Keep watching. I will explain everything. To Edgeworth, 1881, and Pareto, 1896. The two economists developed the theory of indifference curves and defined the basic concept of optimality and multi-objective optimization, MOO. Many large-scale optimization techniques in general, used today can trace their origins to methods developed during World War II to deal with the massive logistical issues raised by huge armies having millions of men and machines. After that, or spread to various fields of industrial technology and economics, which is taken up as the first step in optimization theory, was developed by Danzig G.B. Danzig in 1947, to plan various activities of the United States Air Force. Many methods are developed in late 19th century. If we separate the continuous and the combinatorial optimization type, various techniques developed at different times are listed in the table below. Optimization is the process or methodology of making something, such as a design, system, or decision, as complete, functional, or effective as possible. Specifically, it is a basic subject for engineering in general, and today it has become a mathematical system, with unique content as one of the three pillars of system engineering. 2 are simulation and evaluation. By its very nature, optimization has been used as a tool not only in the natural sciences, but also in social sciences such as economics. Optimization techniques are used every day to solve problems, such as industrial planning for production, resource allocation like investment, scheduling and decision-making for services. For example, how do the world's oil refiners decide where to buy crude oil, where to ship it for processing, and what types of products? How does an airline know how to route planes and schedule crews at the lowest cost while meeting aircraft flight time constraints between maintenance and crew maximum flight times? Etc. Our real-world uses in industry. Optimization is the mathematical procedure of maximizing or minimizing some function over some set, often representing a range of choices available in a given situation. It is a continuous process that begins with inspiration and ends with implementation. Basically, there are many advantages of using optimization. Optimization allows us to deliver products and services with agility and quality. By correcting mistakes and standardizing processes, more products can be produced in less time and with higher quality. Standardized and monitored processes make it easier to maintain compliance. Additionally, optimization constraints helps to clearly define the problem, that increases the transparency. The transparency of the process eases the procedure and contributes to the desired outcome, which decreases the risk and make it reliable. That's why optimization is so important for many reasons explained before. Optimization is the process or methodology of making something, such as a design, system, or decision, as effective as possible. Optimization is essential to achieve the desired competitiveness and become a market benchmark against which other products are compared. Appropriate allocation of production. Design of services. Control of inventory and raw materials can be obtained with the help of optimization. Nowadays, social media are everywhere. We have many social media accounts. By knowing or unknowing, we optimize our time for their use. We only use these media if friends are online, and we pass these media where friends are not available. This is example of real uses of optimization. Optimization helps to reduces cost and increases the revenues. Besides that, one parameter optimization trade-offs in the other's objectives. There are also risk of changing the condition of our assumption in real. Optimization is everywhere with different name. It is to optimize various objectives in production, investment, services. These are known by different names. For production we use cost minimization, but for investment we use profit maximization. Optimization can be used in manufacturing plants to find ways to make machines run better, to purchase raw materials. Optimization is essential to achieve the desired competitiveness and become a market benchmark against which other products are compared. Mapping services makes it easier to standardize and formalize to users. Appropriate allocation of production. Design of services. Control of inventory and raw materials can be obtained with the help of optimization. For small problem, human can easily optimize by their regular usages. But for big and constrained problem, we need proper define and machinery calculation. Based on optimization nature and their objectives, we can divide them as follows. A model with discrete variables is a discrete optimization problem. A model with continuous variables is a continuous optimization problem. The essential difference between optimization problems is a problem with variable constraints. A problem without variable constraints are known as unconstrained. Most optimization problems have a single objective function, but there have been special cases where optimization problems have no objective function, or multiple objective functions. Deterministic optimization knows exactly the data for a particular problem. However, the data may not be accurately captured for various reasons, so we need stochastic optimization. Based on our object, we can divide problem into others different types, but the main using types are explained here. Optimization is the mathematical procedure of maximizing or minimizing. But with number of parameters increases, objective function and constraints higher polynomial state makes them infeasible. So after mathematic techniques there are meta-heuristic and AI techniques are using in recent year. The historical term mathematical programming, widely synonymous with optimization, is a collection of mathematical principles and methods used to solve quantitative problems in many fields. Meta-heuristic offer an alternative approach to optimization that may have some advantages, especially when considering the more complex problem of fitting multiple loops simultaneously. Artificial intelligence is mainly divided into two areas, machine learning and deep learning. These methods require the gradient of the solution with respect to the design variables. Next videos will describe each of the term used in video clearly with helps of code. Keep watching.